Joining me, as you can see, this area of low pressure over Minnesota. Yes, I'm calling this an inland hurricane because it kind of is. It's a non-tropical area of low pressure, but it has some tropical characteristics, such as a big blow-up of convection. You're having, release of latent heat, even though, this is forming over. Okay, let me just make sure. Okay, that's me watching. Let's go to the Minnesota MCV. I call it a hurricane because it technically is. I mean, you're having eastward moving precipitation. This is not along a cold front or on a low pressure system that is part of a cold front. This is actually a MCV. This is a mesoscale convective vortex. An MCV forms usually along a squall line. So basically you get kinks in these squall lines. And yeah, there's a lot of hail. There's like very large hail, especially to the north. So mixed rain and ice pelts, that's not sleet, that's hail. Dime-sized hail. Let me go look at all the hail reports. Pea-sized hail. Okay, so a lot of hail. My guess is that. Jeez, look at these reflectivity values. These are really intense reflectivity values. Yeah, these reflectivity values are extremely insane. I mean, look at this. Look at this. Yeah, Frontenac. So, Frontenac, Minnesota is probably getting, I'm going to estimate about quarter size to $half sized hail. It's not larger. Oh, that's probably larger. That's probably I would say easily probably quarter to probably about $half sized hail. That's pretty large. Maybe even approaching ping pong ball sized. Great. It's not loading. Hate when it does that. See what I'm talking about? See. Frontenac, you're getting large hail. Let's look at rotation. Expires 7 minutes. Probably radar indicator rotation. See, and golf ball size hail. Yep. Tornado and golf ball size hail. Definitely. I mean, that stuff is probably producing golf ball size hail. Keep in mind, this is not a tropical system. Even though it's having rotation, it's rotating. See what I mean? Yeah, let me go to Minnesota MNWX right now. Ethan, what? In price? Oh, thanks. Yeah, you're probably going to have some very large hail with this activity. Let's look at the velocities. You can get some brief spin-ups, but large hail is probably going to be more of a threat. Pea-sized hail. It's probably the south to the northeast. I'm actually looking at correlation coefficient to see if I could find what level the mixing is going on. The rain snow line, okay, isn't that high up. Okay, 5,000 feet. Let's see here. Well, in Duluth, yeah, so there's a possibility that there could actually be some mixed precipitation. Let me look at the temperature. Well, not mixed, but like Nisswa. So Royalton, Minnesota. So around the Royalton area. Like, it's kind of broad, but they're like, it doesn't look like a very well-defined circulation. It's pretty broad. But it's around the Rice area, like Rice. So the center of low pressure is from the Waltab area. So like so this is the area of low pressure. Let me label it. Boom. Yeah, it's around the St. Cloud area, actually. Yep. So the low pressure center is around the St. Cloud area. So it's probably in the 50s right now. Yeah, 62 degrees, northeast wind at 2. My guess the pressure is probably going to be around the 9.8. Yeah, I was going to say like somewhere in the 990s, like 999, 1,000 millibars. Let's check what the barometer is saying, the station pressure is saying. A lot of rain. So that's probably the... light rain with thunder, heavy thunderstorm and wind. So you went from 29 inches down to 2870. So you had a 30 millibar drop. So you were gusting up to like 40 miles an hour in the past like hour. You see rain and wind, 2878, and air pressure continued to drop as the storm got closer. You're still having east-northeast winds. Okay, yeah, so I just checked the air pressure in St. Cloud, Minnesota is at 2870 based on its elevation of 1,031 feet. Convert. $314.2. So 2870, right? That's 972 millibars. Let's convert that to air pressure. 1010 millibars. 1010.73. So it's 1010, about 1010.74. Yeah, so it's between 29.83, 29.85. So yeah, the pressure is dropping, but not by much. So let's change gears and look about how this system formed. This system was a severe weather event that basically formed from a MCV, basically a mesoscale convective vortex. And how did that MCV form? Basically, you had a cold front that's basically stalled across the area. You're having trough in the area. Yeah, I'm walking in an area with really bad reception, so it's probably very choppy. I only have 2 bars, despite walking outside. Yeah, I'm kind of in a Verizon dead zone. There's a lot of piking here. There's a lot of pike, wow. So, okay. I've heard a lot of people talk about lately about climate change and how it's not as bad as we think it is. Saying, oh, we can adapt. Yes, we can adapt. But can the animals adapt? Can coral adapt? Can all the shellfish adapt to the ocean's acidifying? That's the big question you need to ask when you're talking about not just climate change, but ocean acidification. That's a huge existential threat, not just for the ecosystem, but to us as well. While we can adapt to weather extremes, can we adapt to our food chain collapsing? Can we adapt to, food that we rely on no longer, being supported because you're not having bees pollinating because something's gone wrong? Climate change doesn't just mean, the earth getting a little bit warmer and that's it. Climate change means that you're having a whole climate upheaval. The jet stream is out of whack. So what happens when the jet stream is out of whack? Because the Arctic is warming so much. So basically, the jet stream works like this. Hold on. So basically, the jet stream is a flow of fast air. It's a narrow stream of fast-moving current of air in the upper atmosphere, in the middle troposphere, about 30 to 40,000 feet up. Sometimes it varies in height. It's lower in the winter and higher in the summer in elevation. It because as your temperatures decrease, your heights decrease. As your temperatures increase, the atmosphere gets thicker, so your heights increase as the temperature goes up. That's why in the winter, the tropopause is lower than in the summer. That's why you can get explosive development up to 60,000 feet in the summer, because there's more room before the cloud tops reach the tropopause. Of course, in the Arctic, even during the summer, the tropopause is much lower on average, closer to 40,000 or even 40,000 feet. While in the tropics, the tropopause is much higher up, about 60 to 61,000 feet. But now let's talk about the MCV that formed in the Midwest. This MCV is a severe weather system that basically formed as a result of a severe weather event. This is a low pressure system. So let's look at surface products, surface temperatures. So as I was talking about, but the internet was like conking out, so I don't know if y'all heard what I was saying, but I was talking about how because the Arctic is warming so fast, the temperature differential between the Arctic and the tropics is decreasing because the Arctic is warming faster than the tropics. So the tropics are also warming, but at a much slower rate than the Arctic. As a result of that much slower warming, you're having there's less of a temperature differential. And it's that temperature differential that drives the jet stream. With that temperature differential gone, it basically causes the jet stream to weaken. And a weakening jet stream will mean more frequent swings in the jet stream. You're going to have blocking patterns set up. Yeah, so you're going to have more so basically you're going to have blocking patterns being set up. Actually showing freezing rain. Look at that. Because, the lake's being colder, so yeah. Anyway, when you're having blocking patterns because of the jet stream being less potent, these blocking patterns will lead to cutoff flows, more intense storms. Because when you have the jet stream, instead of going more east to west, going more north-south, and getting very sharp amplitudes in the jet stream, you'll get more intense storms. Because when the jet stream does those kinks, along those kinks, you can get very fast-moving streaks. And those streaks can form very intense bomb cyclones, nor'easters. You could get a thing like Sandy, where the jet stream is so inverted that instead of going out to sea, the storm could actually back right into the coast. And that is also as a result of the jet stream weakening. You're getting blocking patterns. You're getting just highs that are stalling. You're getting these mega highs that are just parked over the same area, like that's amplifying the drought in the West Coast. That is all because of warming in the Arctic. Warming in the Arctic is allowing for this very, very, how to say this, it's basically allowing for the jet stream to become very unstable. Oh no, it's dripping sap. Oh God. Oh, do not park under this tree. Wow. Well, now I know what tree this is. This is a sap dripping tree. Yeah. Wow. Thought that was rain, but nope, that's sap. It's dripping sap right now. Anyway, going back on topic. The jet stream, the weakening of the jet stream is why California is having this mega drought. And yeah, you had those atmospheric river events, or what I would like to call Pineapple Express events. Still wasn't enough to bust a drought, and unfortunately, the Southwest didn't get enough rain, and now Lake Mead is at record low levels. It's never been seen before lows. And I actually watched the show, a prediction that something like this was going to happen. It was called Earth 2100. You should really watch it. This was made back all the way in 2009. This was made back in 2009, where it depicted a Category 5 hurricane hitting Miami head on. You know, they were trying to predict as best they can what would happen if we didn't do anything to stop climate change. And yeah, how to say this? We thankfully did ratify the Paris Climate Accord, but here's the thing: because of COVID, our carbon emissions fell a good amount. But now that we're recovering from COVID, you know, there's more people driving. Thankfully, the high gas prices will prevent a lot of people from driving as much. You know, and still you're having COVID, outbreaks. So this will allow for hopefully less emissions, and these really high gas prices will hopefully make carbon or fossil fuels renewables much more competitive with carbon, and allow for a rapid transition away from fossil fuels. This is actually, I was happy that gas prices were low because it meant more money in my pocket, but it was also bad. I was actually a little upset that the gas prices were so low because, here's the thing. I don't think money should be going to the oil companies. I think there should be a law that all the profits from the oil companies should be used to developing renewable energy. It should be mandated that, okay, all the profits that you're making, okay, the money is yours, but you need to do something with it. Invest in renewables. Stop giving the money to CEOs, to, hedge fund managers. Stop, pocketing the money from destroying the planet. ExxonMobil does these great, all these oil companies are doing these amazing greenwashing ads, but they're not fooling anyone. They're not. They're like, oh, we're for electric cars, we're for this, we're for that. Yeah, they support the current thing. They try to make it look popular, but the truth is they don't. They just want money in their freaking pockets. They don't care about the environment like I do. They don't care about like we do. I mean, even Elon Musk, who is, all for environment, he did mass produce Teslas. He did. He did a lot of good for the environment, but at what cost? Workers are not being treated right. No unionization rights. And during that production hell, workers were forced to do overtime. If they didn't, they got fired. The workers, people who were on the floors, at the factory, were treated like shit. Even Elon Musk also, he was there himself and even slept at the factory floor. But the thing is, he also put himself through that too. But the thing is, he's a billionaire. He's ambitious. And yeah, he has Asperger's syndrome. He is on the spectrum. But the thing is, and yeah, Elon Musk, he definitely stutters when he talks. He has that. He definitely, I always kind of thought, okay, he might be on the spectrum. And I ended up being right. He finally confirmed it on Saturday Night Live. But also, Elon Musk, as great of an environmentalist he is, or supposedly is, he's probably just trying to be tech billionaire genius, or tech billionaire. I mean, he's trying to make all this money. I mean, he suggested nuking Mars. Nuking Mars won't do anything. If you want to warm the planet up, here's what you do. It's a much lengthier process. It's longer, but it's going to get it done right. First of all, you have to build a shield around Venus. This is what I talked about. Not building platforms like Cloud City, as I saw. No, that's not going to work. You're going to have to coat the entire planet in a solar shield. Every part of the planet will have to be completely blocked off from the sun. And what will do that is an element called graphene. Graphene is only 1 atom thick. It can block 10% of solar radiation, 10% of solar light. At 20 atoms thick, it's kind of an exponential function. At just a few microns thick, you can literally block all solar radiation from the planet Venus. But to make enough carbon to completely encircle Venus, or graphene at a couple microns thick, it's not that much actually. It's probably, we can do it. And what would that do? in a few thousand years, or even faster, the temperature on Venus will rapidly drop. You will have temperatures plummeting on Venus. It'll be slow initially because all the heat on Venus will still be there, and it will probably continue to warm the planet up for a couple hundred more years, or maybe even a few decades. It depends on how. Because here's the thing, Venus's atmosphere is extremely thick. It's 90 atmospheres of pressure at the surface, 90 to 91 atmospheres. Surface temperature is over 700 degrees Fahrenheit. So eventually, here's what's going to happen. As soon as Venus loses all of its solar radiation, it will still be as hot as an oven for a while. But then eventually, the temperature will start dropping as the upper atmosphere freezes. The atmosphere gets thinner and, over time gets thinner and thinner. This could take as much as a few thousand years or as little as a couple hundred. And what you would find on the surface is mounds and mounds and mounds of frozen, once the atmosphere completely freezes over, you will find mountains of frozen carbon dioxide. I mean mountains of solid, dry ice. You'll literally find it will be miles and kilometers thick. It will be imagine being on 2 Mount Everests. That's how much it would be. You would literally find entire continents made of that stuff. You would find so much carbon, you wouldn't know what to do with it. Venus would be a carbon free-for-all. And it would be white. It would be frozen carbon dioxide. You would also find some frozen sulfur. Not that much, but there's more sulfur on Venus than there is on... Venus has at least a couple atmosphere worth of sulfur. So yes, if you were to transport all of the... Say you were to remove all of Earth's oxygen and all of its atmosphere, everything, and make Earth pure Venus sulfur. So you take all the sulfur from Venus and drop it on Earth. We would have about 2 or 3 atmospheres of sulfur here on Earth. So yes, the atmosphere would be 2 to 3 times thicker and fully made of sulfur. Yeah. So the planet will smell like rotten eggs, and we'll be having, if we could breathe sulfur, it will still be harder for us because, 2 to 3 atmospheres. It'll crush us. Well, it wouldn't crush us, but it would definitely be uncomfortable, to say the least. And yeah, it probably will cause some crushing. Because 2 to 3 atmospheres is basically twice the pressure on you. So, also, here's what you do with that frozen carbon dioxide. You can then transfer it to Mars, warm it up, and now Venus is a frozen cesspool. And then you could take that frozen carbon dioxide and mine it for thousands and thousands of years until eventually there's almost none of it. And then no more greenhouse effect on Venus. And then you could take Venus and make an artificial atmosphere, an artificial Earth. Of course, Venus will be very tropical, even if you only use half the carbon dioxide that Earth has, or much less. Venus will be a good deal hotter because it's closer to the sun. So Venus will probably have an average temperature of 70 to 80 to 90 degrees Fahrenheit. So you'll have a very tropical environment, with the equator, of course, probably being a hot desert, and the polar regions being probably temperate. Well, the temperate regions will be like what you would find on the equatorial regions on Earth. Very hot, humid, wet. Depends on how much water is there. Probably what started the runaway warming on Venus is the disintegration of its solar shield. Hold on, I'm going to stop streaming. It's good now. The storm in Louisiana. I wish I was in that storm in Louisiana, but Mother Nature. You know, Johnny, you're the same way I am. So the good stuff always seems to miss me. But here's the thing, Johnny. I've never seen hurricanes force winds. I mean, I've seen strong tropical storm force winds with Isaias and Sandy, but that's about the worst I've ever seen was like strong tropical storm. Yeah, there's a lot of severe weather. So the flood warning, I think, could be related to river flooding. Flash flood warning? Oh, no. How we're going to colonize Mars and Venus. I watched a video about terraforming Mars and Venus. They try to explain, but here's the thing. Putting cities all over Venus isn't going to stop the whole planet from warming. Because here's the thing. Venus's clouds reflect over 90% of its solar radiation. The 10% that gets through is enough to turn Venus into a inferno. It's enough to turn Venus into an inferno over 700 degrees Fahrenheit temperatures, or like oven temperatures. So the thing is, if you want to cool Venus down like significantly, what you need to do is you need to put a full shield around Venus. Just a couple microns thick. That's all it will take. And but how will you hold it in place? That's the key question. You will very likely need to have it orbiting around Venus. So you'll probably have to, because it will not be able to go onto the planet's surface, because its planet's surface is way too hot. The pressure will absolutely destroy any pylons that go on the surface. So you'll probably have to find the right speed that will orbit Venus synchronously, because of the logistics and the planning is required. You know, with how slow, everything moves, like how slow everything has been moving lately. Like, oh, yeah, just to build a freaking thermonuclear reactor, it's taking decades. When science needs to progress efficiently, there's a plane above me. Let me see what plane that is. So it's above the cloud layer that I'm seeing. It's above the stratocloud layer, just a little bit above it, kind of just a little above, passing through it. So it's a prop. It's definitely a double prop engine. It's a turboprop. There it is. You see that? Yep. Looks like it just took off from LaGuardia, from JFK. 7,700 feet. It says it's going down. It's going to Pittsburgh. And what plane is it? It is a SR-22. So, SR-22. I think it's a Sierra. Yeah, I think it's SR-22. Yeah, I think it's a Sierra. Never heard of SR-22. Yeah, Cirrus. Yeah, that's what I meant to say. Cirrus 22. Yeah. Sierra. I forgot it was cloud type. The same cloud type. Like, I'm so tired right now. Range. Oh, let's look at MPG. Yes. Propeller planes actually have miles a gallon. 10 nautical miles per gallon. 10 nautical miles. .5, that should be about like 12 to 13 miles a gallon. That's actually really good for a plane. Because most jet planes don't even get like a half mile a gallon. Yeah, 12 miles a gallon. So 12. 92 gallons. So let's say you do 92 gallons, which is your maximum fuel load. So times 12 miles. 1,100 miles. So you'll just make it to Miami. You'll just make it to Miami. You'll be like, I just made it. You'll probably make it, but barely. Yeah, you'll probably need to refuel somewhere in northern Florida. More realistically, you'll probably put in somewhere in the high 80s or low 90s. You're probably not going to max it because that's probably, you're going to be overweight. So you'll most likely put in 84 gallons, realistically. Of course, if you're the only passenger, I guess you can do that. Yeah, I guess you'll probably fuel somewhere in northern Florida. I mean, there are some planes that can get 15, 20 miles a gallon. I mean, here's the thing. Truthfully, it is more economically friendly. I mean, yeah, economically friendly to fly, but it's worse for the environment. Because here's the thing. I'm flying to Florida, and the reason I'm flying to Florida is because I got a ticket for $70 round trip. Imagine with gas being $4 a gallon, just driving alone, there and back, you would need approximately, I'm just trying to do fuel calculations, you would need approximately 2,200 miles, 1,100 miles there, 1,100 miles back, plus the driving you'll do there. So let's just do the driving. 2,200 miles, right? And a car gets about 30, on the highway gets about, let's say 29 miles a gallon. You'll average 30 miles a gallon on the highway, most likely. That's 73.3 gallons. And gas being about $4.10. You're going to be spending about $300 on gas. And that's not including the tolls either. You're going to be spending $300 on gas alone for two people, plus about $150 in hotels there and back. That's already $450 plus $30 in tolls. You're already looking about $480. That's $500 just for driving. I mean, yeah, the scenery is great. I mean, when gas prices are lower, it makes more sense to drive. But right now, gas prices are really high. Even when gas prices were in the 2s and 3s, and even in the 2s, it made more sense to fly. I mean, it's a good thing that they're making more fuel-efficient aircraft, like the A320neo, and that's why I'm flying Spirit, because Spirit has a very high seating capacity. Well, sorry, I'm not flying Spirit. Shoot, I'm flying Delta. Forgot. My family made me get a Delta ticket instead. Why Delta? It's because the flight times were very inconvenient. So here's the thing. The Delta A321 has also a pretty good seating capacity, about 194. JetBlue can't say the same. JetBlue is really bad for the environment. I mean, if you really care about the environment, I would honestly fly Spirit or Frontier. I think Frontier is the best because their A320 is an NEO, so it's very fuel efficient, and they also have a very tight seating arrangement. So let's look at the Frontier. So let's look at the seating capacity, right? Passenger max, 194. Spirit, E3. And this is a regular A320. Wow. So let's look here. Yeah, these are the big front seats. Basically, their version of first class or business class. So here, let's not look at the first three. Let's look at this. 1, 2, 3, 4, 5. Wait. That's weird. Huh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. That's 10. It's 20, 21, 22, 23. 23 times 6. Yeah, that's Philippine Airlines. I said Spirit. Yeah. There we go. Okay. 30 times. Yeah, green means the colors actually means good, bad. Yellow means it's okay. Green is the best. Big front, yeah. So 60. So it's going to be 30 or 10, 20, 28. So it's going to be 28 times 6 plus 4. 172. And I have 172 seats. 30 times 6. No, it's going to be... Yeah. That's going to be 20, 21, 22, 23, 24, 25, 26, 27. Wait, let's see. That's going to be 1... 10, 20, 21, 22, 23, 24, 25, 26, 27, 28. So 28 times 6 plus 4. Yeah, so I'm just 72. Spirit A320 Neo. I hear a plane flying over me. Again, going into JFK. That plane is a A319 from Austin, Texas. Yeah, I don't need to screenshot that. Why am I trying to screenshot it? Austin, Texas. Yep. So here's the thing about climate change I was talking about earlier. A lot of people think, because it's cold, we're getting snow in May, we're getting this crazy stuff going on. It's because, climate, global warming is a hoax, right? But no, global warming is not a hoax. It's 100% real. As I said, the Arctic is warming, which is causing instability in the jet stream. The jet stream is becoming less it's becoming less zonal. It's becoming more of like an oscillation. You're having big troughs and big ridges in the jet stream, which used to be uncommon. Like the jet stream would always have troughs and ridges, but they're becoming more amplified. You're getting these super ridges and super troughs now. So you're getting one area being super hot, much warmer than normal. Like hot areas getting hotter, cold areas getting colder. And sometimes you're getting it's completely flipped, where a normally hot area is really cold and normally warm area is really cold. Like a hot area is really cold and normally cold area is really hot. You'll get those. But normally the hot areas are getting hotter, cold areas are getting colder. But of course the hot areas are getting hotter than the cold areas are getting colder. That's what I'm trying to mention. And yes, so overall you're having a overall warming. When you take everything into average, you average everything out, it's increasing. The biggest threat about climate change is not just ocean acidification, but it's the potential extinction of a lot of life on Earth. Going 500 miles an hour, even over like New Jersey, that's crazy. All those dots you're seeing are regional airports. Damn it. You know, those little dots are little regional airports. Other plane. Look at that. 500 miles an hour, 517 miles an hour. Just passed over me flying at about 70 miles an hour. Yeah, earlier today there was a plane flying from the West Coast that was going over 640 miles an hour, which is pretty darn fast if you ask me. Look at the speed briefly. It goes up to above 370. Boom, 371 right over the Great Neck. Great. The plane I just heard, I think that's an Airbus, like one of the new ones, like Neo. Yeah. Yep, A3500. Definitely sounded like it. It sounded much quieter engine. Manila to JFK.
Personality.
That's from. Yeah, this is an international flight. Yeah, this is from the Philippines. Wow. Look at that detour. Look at that detour. Damn. Yeah, they did that on purpose to avoid flying into Russian airspace. Yeah, because of the war in Ukraine. Yep. They deliberately did that to avoid flying into Russian airspace. Yeah, they're boycotting. What? All the planes you're seeing flying over Russian airspace are probably Russian planes. See? From KHV to SVO. KHV to SVO. Trying to see how much it would have cost. Yeah, great. Ugh. Great. That's what I'm doing, like... No. KHV. Wow. Twice a week? So I just literally caught one of the twice a week flight. Aeroflot. Not sure if that's an Aeroflot. SDM 6288. Let me look that up. Russia Airlines. Hmm. Hmm. I'm trying to see how much it would just cost. I mean, fuck. I mean, I don't like Russia. I'm just like trying to see how much it would have cost. Oh yeah, look at that. They have they have a YouTube channel, and they have Telegram, which surprisingly is there's no government surveillance on Telegram, so that's why a lot of people like Telegram. And yet in Russia, even though it's more popular in Russia, I think Russia's like been banning Telegram because it's like, I think in Russia, like, I think they do. Manage online check-in. There, no. So it is Aeroflot. Yeah, it is an Aeroflot thing. It should be fly with us. Yeah.
Anybody could make the line.
Bukhara, Samarkand. Wow. That's actually my country. It is a Muslim country, but I'm not Muslim. It's where my parents are from. Ethnically, I'm actually Zoroastrian, Persian. Also a little bit, apparently, I think maybe some Greek. Yeah, there's some Greek in me. My sister found out, as I thought, I was part Greek, but very little. Most of my facial appearance is pretty much Iranian. Like my father, everyone thinks my dad's Greek. I mean, here's a problem. I mean, look at this. Let's see if in Russian this would be the correct, I think, translation. Oh, let's see. Okay. So it's not. I think they should still do the Russian. Of course, originally Russian was Ukrainian. It says you have to call? Free from Russian Federation. Oh, I am hearing play. That's a Boeing 737 MAX. Oh, 100%. That's a 737 MAX. You hear that? Listen. Yep, that's a 737 MAX. Or A20neo. My bad. Forgot. That's the one I was talking about. The Frontier A20neo. Yeah, I should have realized that. That's a... Yeah. Crap, 4%. Alright, it's time for me to go home now. Yeah, that's one of the rare planes. Russia Airlines. You have to call? That's stupid. Like, this is a website. How to purchase ticket? Airlines. actually. Is the BQS. What is Korean Airlines doing flying over Russia? I guess they didn't. I guess they didn't get the memo. Which is, I'm really surprised about. I mean, they're flying well over Russian territory. Okay. UUS. Cheetah. Looks like it's doing flight training, basically. Yeah, they're training pilots, looks like. Oh, A220 Neo, SBI 5250. Airline. S7 Airlines. Wow. Wow. It's 2 hours 47 minutes. Wow, that's a very long flight. I mean, this is technically the same distance as like an American long haul flight. OVB. That's weird. CCA 595. I mean, it's obviously going to Moscow, probably. CCA 595. Yeah, Chinese Central Airlines. That's the one. UUS. Nope. It's not the one I needed. VVO. Yeah, I think that's the one. VVO. Bingo. Let's go to Moscow. A VVO to SVO. To where? SVO. It's probably gonna find. Please find me rubles. All right. Yeah, right now, because of all the war that's going on, cheapest way to go to Moscow, Russia, is to literally fly to India. Like, I'm not even kidding you. Like, you have to, like, do this whole crazy navigation. I believe, like, no flights originating in the Russian Federation, or no Russian... I think it's either no Russian planes can land in the United States, but like, or no flights originating. I forgot what I think it's no flights. Like no Russian aircraft can fly like registered in Russia. So maybe like, but a lot of airlines have banned flights. Like I mean, maybe Indian Airlines might do a flight from Russia to New York, but okay. No! Damn it. Boom. Huh. Yeah, see, there's no censorship. See, English. Online. My booking. See? JFK? Ha. How many rubles? $840. Okay, not bad. pensioner. In Russia, it's pensioner, pension. Here's the thing about Russia. If you live in Russia, they while they're very socially right wing, they're economically pretty progressive. Healthcare and education is pretty much free in Russia, but socially, Russia is very, very far to the right. I mean, keep in mind that flying from Moscow to Russia, this is a round trip. This is the same equivalent of flying from New York City all the way to Moscow. This is you're literally flying 4,000 or 5,000 miles. This is incredibly far. This is obscenely far. And also Russia is a very, very low income. $348, not bad. $282. Let me look at that. I mean, they are with stops. Garcia. Oh, there it is. Ah. I'm back now. So yeah, I was looking up the flight.